Good day everyone. Today we're going to solve a problem in Chapter 5, Fundamentals of Fluid Flow from the book Fluid Mechanics and Hydraulics, 4th edition by 𝙿𝚀𝚰𝙰𝙰. So here's the problem. A 100 mm pipe is connected to a 75 mm diameter pipes. If the velocity of flow in the 100 mm pipe is 2 meter per second, what is the velocity of flow in the 75 mm pipe? Determine the volume flow rate in the 75 mm pipe. First, let's put down all the given values. Diameter 1, 100 mm, diameter 2, 75 mm, and V1 or velocity 2 meter per second. First, we need to find the velocity of flow in 75 mm pipe given in the question that a 100 mm diameter pipe is connected to a 75 mm diameter pipe, so we can use the continuity equation to relate the velocities in the two pipes. The continuity equation states that the volume flow rate AV is constant along a pipe, where A is the cross-sectional area of the pipe and V is the velocity of flow. Since the volume flow rate is constant, we can write A1 V1 is equals to A2 V2, where the subscript 1 and 2 refer to the 100 mm and 75 mm pipe, respectively. We can assume that the fluid is incompressible, so the density is constant. We also know the diameter of each pipe, so we can calculate the cross-sectional area using the formula A is equals to pi t squared over 4. Plugging in the values, we get a 0.007854 meter squared and 0.004418 meter squared, where V1 is equals to 0.1 meter and D2 is equals to 0.075 meter. Plugging in the values, we get 3.56 meter per second. So the velocity of flow in the 75 mm pipe is 3.56 meter per second. Next, we need to determine the volume flow rate in the 75 mm pipe. The volume flow rate is the product of the cross-sectional area and the velocity of flow. We can use the same formula as before. Plugging in the values, we get 0.0157 cubic meter per second. So, the volume flow rate in the 75 mm pipe is 0.0157 cubic meter per second. This is for today's problem. We hope you learned something from us and kindly see our next videos for more information. Thank you.